Okay, so this video should help you with section 2.2, which is just the rules of talking about first and second derivatives. Okay, so the first thing we're going to talk about is the first derivative rule. We already talked about this in class. The first derivative rule is pretty straightforward. It's basically saying that when you find a derivative, a first derivative, if that first derivative is positive, then the function is increasing. If the first derivative is negative, then the function is decreasing. So it's pretty straightforward. It's increasing if positive, decreasing if negative. Okay, which brings us to the second derivative rule. Second derivative rule is the same idea. Again, well, first thing you have to do is you have to take the second derivative. You know, the second derivative is just the derivative of the first derivative. If that second derivative is positive, then your function is concave up. F double prime of x is positive. And then it's concave down if f double prime of x is negative. So you have to keep those rules in mind when you're working through these. Lastly, one of the problems is going to actually ask you first, it's just going to say, well, what if f of x itself is positive or negative? What does that mean? So all that means is, remember, f of x is just the same thing as y. So if f of x, so we'll do this in red, if f of x is negative, that means the y values are going to be in the negative quadrants. All the y values have to stay negative. If f of x is positive, that just means the graph itself has to stay in the positive y values. So it has to be in the top of the graph. So that's all f of x itself, whether it's positive or negative, means. Okay, and I thought this chart was really helpful. Try to go through this chart by yourself and see if you can look at the graph itself and determine whether or not f prime of a is positive and f double prime of a is positive or negative. If you go through each one of these graphs and try to do that on your own, I think it's really helpful if you just pause the video. And then lastly, well, I'm going to go ahead and do one of these problems with you to kind of give you an idea how these work. So for example, if we're given a function that has the point 2, 3, 4, 0, and 6, negative 3 on the graph, we know that f prime of 2 is 0. And remember, f prime of 2 means increasing versus decreasing. So this is going to be neither increasing versus nor decreasing. At x equals 2. So because of that, it's got to have a slope of 0 at x equals 2. So it's going to obviously, at the point at x equals 2, it's going to have a slope of 0. Also, f prime of 6 is 0. So where the x value is 6, the graph is going to also have a slope of 0 because it's neither increasing nor decreasing. Next thing we're going to find out is that f double prime of x is negative. So that's going to mean that it's concave down. And it's going to be concave down for x less than 4. So all values of x less than 4, which means if we start at x equals 4, which is going to be this point, we have to draw a curve that's concave down. So it's probably going to look something like this, right? Up to this value where we have no slope, and then we're going to continue going down something like this. I don't know exactly where it goes, but Okay, so that's for x less than 4. Then also, when x is equal to 4, there is no concavity. So that means this must be an inflection point. At x equals 4. So let's just make our inflection point here, which means the concavity is going to change. And let's see. When we see here, the concavity f double prime of x is greater than 0, so this is going to be concave up for all x values greater than 4. So we're going to kind of switch our concavity here. And I know my drawing is not great here, but do you see how? I'm going to try again. Try to erase that. And draw our curve kind of like that. We're going to get the 0 slope, and we're going to go right back up with a concave up value. Whoa, wait. So yeah, so this is roughly what this graph is going to look like. Obviously, we would need more information to really figure out what these, ends of the graph are doing. But the main point I hope you see is the two values where the derivative is 0, which means there's no slope of the tangent line, and the inflection point. And remember, the inflection point is where there's no concavity. So it's going to switch its concavity, which I know my graph leaves a lot to be desired, but hopefully you get the picture. So I hope this video helps.